So in this video, we're going to be discussing some terminology. Alright, so to start off with, we're going to be looking at these four terms: atoms, molecules, compounds, and mixtures. So an atom of an element is just a single particle of one element. So this could be an atom of hydrogen or an atom of oxygen or any of those elements on the periodic table. Molecules, however, are two or more atoms bonded together. And these can be two of any atoms. It can even be two of the same atoms. So if you have a hydrogen atom bound to another hydrogen atom to make hydrogen gas, that right there is a molecule. A compound, however, is different. So a compound is a type of molecule, but it must have two or more different atoms bonded together. So this means that this hydrogen molecule is not a compound because it only has one type of atom making that molecule. However, something like water, where you have oxygen and hydrogen, that is a compound because you have two different types of atoms. So that's the difference between a molecule and a compound. A compound is a molecule, but a compound must have two or more different types of atoms, whereas a molecule can have two or more of the same types of atoms, or it can have two or more different atoms. So this water molecule here is still a molecule, but it is also a compound. A mixture, however, is two or more atoms or molecules in the same space. So mixture is anything that isn't made of one type of molecule. So this could be something as simple as water with salt, or something as complicated as cake mixture. Cake mixture is still chemically a mixture. There's a bunch of different molecules all in the same space. Now, there's two different types of mixtures that you need to know about. They are homogeneous and heterogeneous. So what do these two mean? So a homogeneous mixture has a uniform spread of atoms and molecules. An example of a homogeneous mixture might be a tub of water with salt diluted all throughout the water. So if I take three different samples of this water, so from here, here, and maybe one from the back, doesn't matter where I get my sample from, each sample is going to have a very similar salt to water ratio. So the salt is uniformly spread, and if I take a sample from here or here or here or here, it's all going to have roughly the same amount of salt per litre of water. Another example of this might be a cake. Assuming that you did a very good job mixing the cake mix before you put the cake in the oven, if I take a slice of cake from here, or maybe a slice of cake from here, each slice of cake is going to have sort of the same amount of sugar, the same amount of flour, the same amount of eggs. A heterogeneous mixture is very different. Imagine you have a bowl of chicken soup. So you might have noodles in it, and on one side you might have some chunks of chicken, and on the other side you might have some vegetables. I know this is fairly crudely drawn, but bear with me. If I take a sample of the chicken soup from here, I'm going to have lots of noodles and lots of chunks of chicken. But if I take a sample of the chicken soup from here, I'm mostly going to have vegetables and maybe some noodles, right? And if I take a sample of the chicken soup from the bottom of the bowl, I'm going to have mostly soup and not many noodles or veg. They are not uniformly spread across the chicken soup. Another example of this might be a pizza. If you have a pizza and the toppings are not very well spread, then if I take a slice from here, I might end up with a lot more pepperoni than if I took a slice from here, right? And so this is not a homogeneous mixture. This is a heterogeneous mixture. in chemistry, a homogeneous mixture can also be known as a solution. So if you ever hear on TV when someone's doing chemistry that they need a solution, that is just a mixture where all the chemicals are mixed uniformly. And surprisingly, many organic things like most rocks or most types of wood are actually not homogeneous. They're actually heterogeneous. And this is because of the way that minerals might vary in a rock or the way that a grain might vary in a piece of wood. Before I finish this video, I just want to show this flowchart from the book Chemistry, the Essential Science. So if you have a piece of matter, you can ask yourself, is it uniform throughout? Like salt and water, like air, like a lot of those things. If no, then it's a heterogeneous mixture. If yes, then you know it's homogeneous, but you have to ask yourself, does it have a variable composition, which is another way of saying, does it have two or more different types of molecules or atoms? If yes, then it's a homogeneous mixture. If no, then it's a pure substance made of just one type of molecule or one type of atom. And lastly, can the atoms or molecules that make up this matter be separated into simpler substances? If yes, then it's a compound. If no, for example, you just have a single atom, or maybe a pair of the same type of atom, then it is not a compound, but it is just an element.